Welcome to AskPrep, your trusted companion for NEET and JEE preparation. Today we will study about a very important topic of chemistry, which is hydrocarbons, alkanes, alkenes and alkynes reactions and properties. Hydrocarbons are the fundamental building blocks of organic chemistry, forming the basis of fuels, plastics, and many other essential compounds. They are classified into three main categories: alkanes, alkenes, and alkynes. Understanding their reactions and properties is crucial for mastering organic chemistry, especially for competitive exams like NEET and JEE. Alkanes are the simplest hydrocarbons, consisting only of single bonds between carbon atoms. They are also known as saturated hydrocarbons because they contain the maximum possible number of hydrogen atoms. The general formula for alkanes follows a simple pattern, and their structure influences their chemical behavior. Alkanes are relatively inert due to the strength of their C to C and CH bonds. However, they do undergo certain characteristic reactions such as combustion and substitution. Combustion is one of the most significant reactions of alkanes, where they react with oxygen to produce carbon dioxide and water, releasing energy in the form of heat and light. This is why they are widely used as fuels in the form of methane, propane, butane, and gasoline. Another important reaction of alkanes is substitution, typically occurring in the presence of ultraviolet light. In this reaction, a hydrogen atom in an alkane is replaced by another atom, often a halogen like chlorine or bromine, forming halolkanes. Alkenes, on the other hand, contain at least one double bond between carbon atoms, making them unsaturated hydrocarbons. The presence of a double bond increases their reactivity compared to alkanes. One of the most prominent reactions of alkenes is addition, where the double bond breaks and new atoms are added to the molecule. This is a key reaction in industrial and laboratory processes. Alkenes readily react with hydrogen in the presence of a catalyst in a process known as hydrogenation, converting them into alkanes. This reaction is widely used in the food industry to convert vegetable oils into solid fats. Another important reaction is halogenation, where alkenes react with halogens like bromine or chlorine, resulting in dihalokanes. The reaction with bromine water is a common test for the presence of alkenes, as it leads to the decolorization of the solution. Alkenes also undergo polymerization, where small alkene molecules, called monomers, join together to form long-chain polymers. This reaction is essential in the production of plastics like polyethylene and polypropylene. Alkynes, the third category of hydrocarbons, contain at least one triple bond between carbon atoms. They are even more reactive than alkenes due to the presence of the highly energetic triple bond. Alkynes undergo addition reactions similar to alkenes, but in a stepwise manner. When alkynes react with hydrogen, they first form alkenes and then further hydrogenation converts them into alkanes. One of the most important reactions of alkynes is halogenation, where they react with halogens like bromine or chlorine to form tetrahaloalkanes. Alkynes also participate in hydration reactions, where they react with water in the presence of a catalyst to form carbonyl compounds such as aldehydes and ketones. This reaction is significant in organic synthesis. The physical properties of hydrocarbons also vary based on their structure. Alkanes are generally nonpolar, making them insoluble in water but soluble in organic solvents. They have relatively low boiling and melting points, which increase with molecular size. Alkenes and alkynes, due to their unsaturation, have slightly different physical properties but follow similar trends. The presence of a double or triple bond affects their density, solubility, and reactivity. The structural isomerism of hydrocarbons also plays a crucial role in their chemical behavior. Isomerism in alkanes is mainly due to branching, while alkenes and alkynes exhibit both structural and geometric isomerism. Geometric isomerism, also known as cis trans isomerism, is particularly important in alkenes, where the position of substituents around the double bond leads to different physical and chemical properties. Alkynes, the third category of hydrocarbons, contain at least one triple bond between carbon atoms. Due to this high degree of unsaturation, alkynes are even more reactive than alkenes. Like alkenes, they undergo addition reactions, though in a stepwise manner. Hydrogenation of alkynes can yield either alkenes or alkanes, depending on reaction conditions. Alkynes also react with halogens, leading to the formation of tetrahalo compounds. One unique reaction of alkynes is ozonolysis, where they break down into smaller carbonyl compounds upon treatment with ozone. This reaction is valuable in identifying and studying the structure of complex hydrocarbons. Industrially, hydrocarbons play a crucial role in the production of fuels, plastics, and pharmaceuticals. Cracking is a widely used process where larger hydrocarbons are broken down into smaller, more useful molecules like gasoline and ethene. Polymerization of alkenes forms important materials such as polyethylene and polypropylene, used in packaging and manufacturing. Alkynes, particularly ethine, find applications in welding torches due to their high combustion energy. Understanding the reactions and properties of hydrocarbons is essential for mastering organic chemistry concepts. Their widespread applications in fuels, plastics, and pharmaceuticals make them one of the most significant classes of compounds in chemistry. Mastery of these topics is not only crucial for academic success but also for understanding real-world chemical processes and industrial applications. By studying these fundamental reactions, students can develop a deeper appreciation for the role of hydrocarbons in everyday life and advanced scientific research. Thank you. We hope this video has helped you gain a clearer understanding of hydrogen and its compounds, especially the fascinating role of heavy water and isotopes. If you found this video helpful, make sure to like, share, and subscribe to AskPrep for more in-depth chemistry lessons. Keep studying, stay curious, and good luck with your exams.